Oh, hi Year 10, sorry. Put that just there. I have got a friend with me today to help, but today we're learning all about density. Now, I have got a little friend today. It's no surprises for the end, I'm afraid. He's very well camouflaged. He's the black rabbit sooty. Now, how would I find his density? I could mass him on my scales here, but how would I find his volume? Now, you're really good. You did a brilliant job with your definitions. And up here I've got density, so we're going to pop the date in the title today, density, May, whatever it is that you're doing it. And it's mass divided by volume. Now, if I was going to mass Sooty the rabbit, I might find his mass in kilograms. And then I could find his volume in metres cubed. Or I could use grams, because there's thousands of grams in a kilogram. But how many centimetres cubed are there in a metre cube? Now, have to think about that. It's a really good question, okay? Now, the other thing you need to think about is Sooty a regular object or an irregular object? Regular objects are things like a OXO cube, which is perfect. You can do all of this at home, which is brilliant. Or a can of beans. That's, again, a really regular object. You can find its volume. Or a bar of chocolate. So you could do all those different things and find. So you've got to find the density of 5 regular objects and 5 irregular objects. So I can't do Sooty. It would be a bit mean. You're not supposed to get rabbits wet. But if I was to do Sooty, he's not looking very keen now at all, I would have to plonk him in some water. And look how big his paws are. Now this is a really good thing for next week, because we're doing something different next week. I might need to clip your claws. He's got really big paws, which reduces something else for Sooty. So I'll pop him down and I'll get on with it. But he's my camouflage rabbit, so if you can't see him very well, I'm sorry, he's just here. And I can't see what I'm doing, so I'm on the back of the iPad, so I'm sorry. There we are, Sooty. He's been a great help yet again. So you need the equation density as mass divided by volume, add some units to it, kilograms or grams, and metres or centimetres cubed. Regular objects are things like my OXO cube, so you're going to do 5 of these at home, so you need a ruler and an OXO cube, and you can just measure it. Handily, you can use anything that's a cube. We have a planet cube and a dice, anything square. A packet from Amazon, doesn't matter at all. If you measure it, this is 2 centimetres, so to find the volume of my 2 centimetre cube, it's 2 times 2 times 2, so 2 times 2 times 2 equals 8, so that's 8 centimetres cubed. Now if I was to put my lovely box that my scales from Amazon came in, if I put my OXO cube onto my scales, they only measure to the nearest gram, so it's fair enough. It says it's 6 grams. Okay, now they're just kitchen scales. So if I was going to put my OXO cube into my results table up here where I've got my mass, volume and density, the mass of my OXO cube is 6 grams. The volume is 8 grams, so I have 6 divided by 8, which is 3/4, isn't it, which is 0.75. And you can do that for lots of different regular objects. You don't have to have a set of kitchen scales. I could have used the box. On the box of my OXO cubes, it says they have a mass of 106 grams in total. So when you look inside the packet, there's 18, so you could work it out, and the mass of each OXO cube is 5.8 grams. You just do 106 divided by 18, and it's 106 grams. Now I'm going to get wet for the next bit. So that was 0.75 centimetres cubed. Now, there's loads of other stuff you can find the density of. A chocolate egg. If I was to find the density of this, do you think it would float or do you think it would sink? If I was going to pop, it's hollow. Unfortunately, my children's disappointment, it's a hollow egg, so it would probably float because it's got air inside it, which is less dense than water. But you do need to be able to find the density of water, which is part of the core practical. So I've, again, really lucky, I've got my bottle, and most of you, I think, will have a bottle that you could put water in at home. Now, on the side of my bottle, it says 1.5 litres. So that's the volume of my water inside here. And if I put it on my scales, it says 0, so I'll pop it on. This is how I know my scales are correct. It says 1,542 grams, which is perfect. Now, obviously I've got the mass of the bottle here as well, so what I did, I emptied all the water out and I just filled it up with tap water and found the mass of the bottle and took it away. So if I was going to put in my results table, you definitely need to do water, so if you put water in there, the mass was 1,542. I need to take away the mass of the bottle, which was about 40 grams, to give me 1,500. The volume is 1.5 litres, which is 1,500 millilitres. So the density of water is approximately equal to 1 gram per centimetre cubed, which is really good to realise because a lot of things they'll ask you about is whether something floats or whether it sinks. And that depends on how dense it is. Now I've got two, and I might get wet here, cans of Coke. I've got a original Coke and I've got a Diet Coke, and I got them on my once weekly shopping trip. City's tickling my toes now. So I'm going to put my regular Coke into my jug of water and hope I don't get very wet feet. Yeah, I've got fairly wet feet. But it sinks and it sits on the bottom, okay? What do you think will happen with my Diet Coke? It's a good job I didn't do this in the living room. If I put my Diet Coke in, it floats. Now, even without the bubble underneath, it floats. Now, I'd like you to think about what the difference is between real Coke and Diet Coke. And also, why I need to play more now for real Coke. Please don't drink real Coke. But you can easily find the density of a can of Coke. I would pop it on the scales, and this is the interesting difference between Coke and Diet Coke. If you have got some kitchen scales and you can put them on the kitchen scales, obviously you must generally mash your objects first, because some things will get wet and you can't get the water out of them. It will affect their mass. So I put my normal Coke, my Diet Coke on there, and that says 356 grams, which is really interesting because it has a volume of 330 millilitres in there, so I can easily pop that in my table. Then I put my, it's not on zero, my red Coke on there, and that says 365 grams. So my sugared Coke has got higher mass than my non-sugared Coke. So what you need to do is you'll need to think about regular and irregular objects, why I can't find my irregular object. If I was to find the volume of an irregular object, I'm quite lucky. If I wanted to do this marker pen, we'll do beans in a minute, remind beans in a minute. If I wanted to do this marker pen, it's got a funny handle on it, it's got funny bits at the end and all the rest of it. Now, I'm lucky enough to have a measuring cylinder at home. Now, I can read off where it is now. It's on 70 millilitres now. Do you think my marker pen will float or sink? Do you think it's more dense than water or less dense than water? It's a really good question. If I pop it in, it floats. Now, in order to make this a good, accurate experiment, I can't just find that much volume of it. I've got to pop it in with my finger so that it's just underneath the water. And funny enough, it goes up to 100 millilitres. So I've made sure that the volume of my marker pen is 30 millilitres. Now, the other thing that's really important when we're talking about this, I'm just going to draw up my pen, is the fact that a millilitre is the same thing as a centimetre cubed. We generally use millilitres for liquids and centimetres cubed for solids, but they're the same thing, so it doesn't matter. It's good for your chemistry, so you can compare it. So if I put the mass of my marker pen, sorry, it's not very flat, this is why it doesn't work very well. If I mass my marker pen, and it's 15, so it's 15, the marker pen, it's 15 grams, it's got a volume of 30, so its density is 0.5 grams per centimetre cubed, so it's definitely going to float because it's less than 1, which is what the density of water is. There's a cool practical to do with this, where you have to find densities of regular and irregular object. Oh, there's another regular object here. If I had a bar of chocolate, it says on it its mass, it says it's 46 grams. I know it doesn't include the packet, but that's not fair. If it was you have to imagine it's a regular bar of chocolate. I could measure its length, which is 12 centimetres. Its height is about 1.2 centimetres, and its width is 3 centimetres. So I just put those in, I find the volume of it, I know that its mass is 46 grams, and then I will work out the density and pop it over there. So you can tell me whether you think your chocolate is going to float or whether your chocolate is going to sink, okay? They will inquire you to be able to predict. Now, the last thing that you'll need to do is an egg, potentially. Oh, I could definitely find the density of, this was my Easter rabbit and I haven't eaten it yet, which is very good because I think it's super cute. Now, I could find the density of this. It's hollow. So what I'd have to do is break it up into bits, and I could pop it in my measuring cylinder, and if I zapped it in, I'll take the cover off. This one says it's 200 grams, take off the label, popped it in my microwave, it become a liquid, so if we could go through a physical change, I could find the volume of my liquid. I know the mass is 200 grams, so I would be able to tell the density of the chocolate that my rabbit is made out of. Okay, so, and that's an irregular object. I've got another irregular object. This water bottle here is easy because it's a really weird shape. Elise had this the other day when we were out. It's a really weird shape, but it tells on me it's 270 millilitres. So all I'd have to do when it was full is mass it, pour out the liquid, then find the mass of the empty bottle. I know the volume is 270 millilitres, so I could find the density of whatever was inside my bottle. Okay, they will ask about the difference between eggs floating and sinking. So I've got an egg inside my beak here. You can use a mug, you can use a cup, you can use anything you like. Now, I can pour my water in. Do you think my egg is going to float or sink? Now, is it a gone-off egg? I know it's hard to find eggs. These are eggs I've had for ages these days. Is it going to float or is it going to sink? So as you pour the water in, this is normal tap water, okay, at room temperature. As I pour the water in, my egg is just about top down on the bottom. It's just about, it was very nearly hovering. What I'd like you to do at home and have a go at this, it's quite straightforward, is most people will have a mug, you need some salt and a spoon to stir, okay? If you add salt to the water, what will happen to the density of the water? Think about going swimming in the sea. See how many grams of salt, you can do that with your table, you can just do it with spoonfuls, how much spoons of salt you need, and you should be able to get it, you can get it so that your egg pretty much hovers right in the middle of your mug, your beaker, your glass. You can do it in the measuring cylinder, if you've got a jug at home you could use that. Anything like that you could do. I've even got one of these measuring things in my kitchen cupboard. Your parents might have some of this stuff. Please go and have a go at doing something, because it's much better than just watching more YouTube clips. And have a look, see how much salt it takes you to get your liquid thing. And then, if you're really lucky like me and you've got a measuring cylinder and a beaker at home, you could just empty it and some scales. I could pour my salty water, I could zero that once my measuring cylinder's on. I could pour my salty water into my measuring cylinder. That will tell me the volume of the water. It will also tell me the mass of the water, so I can find the density of the liquid that the egg is hovering in. Okay? So, hopefully, what you can do in this week's lesson is learn to use the equation, density is mass divided by volume, with the correct units. Realise it's an awful lot more centimetres cubed in a metre cubed, and work out how many times more. Find the density of 5 regular objects, anything around your house, it doesn't matter, you can make up the mass, doesn't matter at all, and 5 irregular objects. Put them in a table like this with mass, volume and density, see where they're going to float or where they're going to sink, and predict what you're going to do. Then you can have a go at the egg challenge, which is really good, and things you can't measure or calculate the volume of, so there could be alternative ways of finding it. And then we'll just 2 challenge questions. What does salt do to water and why? And icebergs. Why do icebergs float? We've looked at energy conversions and conduction, convection and radiation and heat energy transfer in those and the different densities. Now I said that there's no gaps between particles in a liquid, but as you increase their kinetic energy, their temperature will rise and the particles start to vibrate faster, meaning they do get slightly further apart, which is what causes convection currents in the Earth's crust and